Hey there, guys. As I said before, I'm going to be recording this so that you guys get a chance to watch it. We're going to pick up where we left off today with proving the alternate interior angles theorem, I believe. Give me just a second and we will take a look at that. All right, so here's where we are. We are presentation mode. Okay, so here's where we're looking at it. And right now, this is the alternate interior angles theorem. We talked about this a little bit yesterday, but we're talking about the fact that if you got two parallel lines that are cut by this transversal, then the alternate interior angle pairs are congruent. So 1 and 3 or 2 and 4. And so now we are moving on to prove it. And so here's the alternate interior angles theorem. And what I'm going to do is take you through this proof if I can. So I am going to try to share this looking at the camera. Boom. Okay, so here's what we're going to do. I'm going to take you through what this proof looks like. And so we've got L is parallel to M. So I'm going to mark that. L is parallel to M. And we know that this is set up and we want to prove that angle 2 is congruent to angle 3 because those are alternate interior angles. So our first step for this is going to be L parallel to M. And we know that because it is given. Now, I'm hoping this is actually focused enough that you can see this. But if you can't, well, you know, what are you going to do? That's fine. That's better. All right. Now, for part 2, what I'm going to say is that because we know these are parallel lines, then I know that corresponding angles are going to be congruent. So I'm going to say that angle 3 is congruent to angle 1. And the reason I know that is because of the corresponding angles postulate. And here's the thing. When I say the corresponding angles postulate, the other thing that I could say is that corresponding angles of parallel lines are congruent. I could totally say it that way and that would be fine, but that's just kind of a way that I want to look at it. Now, if I look up here, the other thing that I want to do is say, I look at angle 1 and angle 3, and we know they're congruent, so I'm going to mark those. Angle 1 is congruent to angle 3. But if I look at angle 1, it's right across from angle 2, and they're vertical angles. I know that angle 1 and angle 2 also have to be congruent because they're vertical angles, the vertical angles theorem. So if angle 1 is congruent to angle 2, I know that because of the vertical angles theorem. Now, 1 is congruent to 2. So if 3 is congruent to 1 and 1 is congruent to 2, then I could say that 3 and 2, those bad boys are also congruent. So angle 3 is congruent to angle 2. And since I'm using congruence, 3 went to 1, 1 went to 2. This is the middle one, so that gets canceled out. And we can say by the transitive property of congruence that these two things are congruent to each other. Now, here's the deal. They want us to prove that angle 2 is congruent to angle 3. We've proved that angle 3 is congruent to angle 2. I'm fine with that. Leave it that way. If you want to flip this, you could say the symmetric property of congruence. It's a pain in the butt. Nobody wants that. That's not something that anybody will like you if you do that. They'll say, this is nitpicky. Why would you do this? It's terrible. So nah, I'm just kidding. If you do want to do that, that's fine. But for this, I'm leaving it here because this is enough to show us that the alternate interior angles theorem is true because we took it from the beginning to the end and we proved it. So now I'm going to take us back to our presentation. So let's see if I can get us there. Boom, we're at the alternate interior angles theorem. We proved this, so now we're on to the next thing, the last two theorems. And we looked at those a little bit yesterday, but I want to make sure. The alternate exterior angles theorem, same situation, but what we're looking at now is that 8 and 6 are congruent and 5 and 7 are congruent. The proof of this is almost exactly the same as what we just did there, because if you think about it, if I slide 7 up here as corresponding angles to this angle here, that is going to be a vertical angle with 5. So 5 goes to whatever this one is, which goes to 7. Same thing with 8. If 8 slides up here as a corresponding angle to this one, this angle here is going to be congruent with angle 6, and then we can do it just like we proved that last one. That's how we prove the alternate exterior angles theorem. Same side interior angles. In fact, what we're going to find anytime you're dealing with same side angles, they're going to be supplementary. I almost screwed that up because they add up to 180. The reason being, if you look at this, and I'm going to help you through this a little bit, it's the same general corresponding idea. Let's say I take 3 here and I slide that up to there as corresponding angles. If you look there, we have a linear pair. This linear pair has to add up to 180. So if I just slide that one down here, 3 and whatever that angle is up there, those are going to be equal, which means that these two also have to be supplementary for the same reason. Same thing with 1 and 4. And that's how we go to prove this. And again, you're proving these for homework, fools. And you know what? You are proving these for homework, but I just kind of told you how to prove these for homework. That's something that you want to be able to do. Now, oh, here comes our old friend. You guys love this guy. Who's our old friend? Our old friend algebra. Wink. That's right. That's the next thing that we're going to do. And that is like, I was talking to Mr. Michener about this. We kind of call this is like our angle gazing, our angle searching. And that's the way that a lot of this stuff goes. Because when you're going to look at this, you're going to start and they're going to give you something like this where they say, hey, look, we got two parallel lines. We got to find X. And you got to know enough about this to figure how to do this. Now, there's going to be two problems here. They're going to look like this, find this X and find this X. I'm going to do this on paper as well because I think it's going to be a little bit easier to see my work. But this is how they sneak algebra in. And that's what a lot of what you're going to be doing is going to be. So let me move my sharing back to the camera and we'll see if that's going to be something that will actually work. So there's our first one. We got two parallel lines because they told us. And we've got these two angles that are right here. Now, if I look, they're in the same place, which makes them corresponding angles. We know that corresponding angles of parallel lines are congruent, which means that this and this have to be equal to each other. So that's the first thing that I have to do is set up my equation. 2x minus 45 from the top is equal to x plus 30 from the bottom. And that's going to be what we're going to be looking at here to solve our equation. Now I'm just going to take you through it really quick. You're going to subtract x from both sides because you're going to try to get the x's on the same side. So 2x minus x is x minus 45 is going to equal 30. I'm going to add 45 to both sides here. And if I do that, this cancels out and I get that x is equal to 75. Now that is not 75 degrees, that's just 75. If I want to figure out what the actual angle measures are, I'd have to plug it back in and tell you that this one was 105, as would this one be. But I don't need that. I just needed to know what x was. And that is how we get that one right there. So we've solved this one. And one more. We're going to solve this one right here. And I dig this because you get so used to setting them equal to each other. You got to think about this one for a second. Parallel lines, they're on the interior, but they're not alternate. They're on the same side of the transversal. We just talked about this before. Same side interior angles are supplementary, which means if I'm setting up an equation with this to solve for x, I'm going to have to say that that 13x plus 23x is going to equal a total of 180 because they're supplementary angles. Now, this shouldn't be terrible for me to go through and do, but it is a way for us to do this. So 13 plus 23 is 36x is equal to 180. If I then take that and divide by 36, I'm going to get whatever the heck 180 divided by 36 is. This is something that I should have worked out beforehand, but of course I did not. So now I'm pulling my phone out in front of you, embarrassingly, to type in the problem. 180 divided, oh, that's 80. And I can't even type. Guys, it's killing me right now. I don't know what's going on. 180 divided by 36 is that x is equal to 5. And that's what we're looking at here. Now, I could plug that in to show that they add up to 180, but I just asked for x, so I don't need to do that. We should be in relatively good shape, okay? So that's how we do some of the equations that we're looking at. And if it feels like I'm sort of rushing through this, I am, because when I'm done with this, I have to take my stepson and we are going to be going to his gymnastics class. So I'm going to try to come to a conclusion of this as quickly as possible. So with that being said, we just solved for both of these x's. So now you got your homework and a dope pick of a road that just happened to be a part of this. And I really thought that was kind of funny. So if you're looking at this, down the road, your goal is here to go through problems 6 through 33 and 37 through 40. When you do this, make sure that you upload a picture of your explanation for 32. Kind of treat it like a proof. You're going to explain why you're doing some of these. And it's not terrible, but it is something we want you to do. I really would like for you with these problems, do some good practice. They're not bad. The 6 through 33 are your sort of basic ones, having you go through it. Your two proofs of the two things that we just saw, the two theorems that we talked about are in here. This 37 through 40, these are real good problems. These are good extension problems. We'll talk about a couple of them next week because I really like the thought process that you have to go through to do some of this, but that's kind of where I'd like for us to be. So that is, I believe, the end of what I need to do. So with this video, I'm going to stop. and say to you guys, you've got enough. Now go in, take care of this, and finish your test, because that's what we're going to be doing. So y'all have a wonderful weekend, and it was good sharing this video with you. Bye now.